Welcome back to my channel, Statistics for Applied Linguistics. I'm Dr. Marnie Menegra, and in this video, we are going to look at what to do with a small sample size. And so this is an introduction to the Shapiro-Wilk test. So I'm going to explain this test, and then we will go live into JASP so you can see how it's done. But first, we're just going to ask, why does the sample size matter? So why does it matter if you have a small size or a large size sample? Well, let's look at it at an example here. So for small sample size, let's look at eye color. So let's say your sample only includes one participant and your participant has brown eyes. We cannot conclude that everybody has brown eyes because this one person had brown eyes. So we cannot make a generalization that governs the entire population based on a sample size of one. Now, we're also going to fall into problems if we have, say, around 10 participants. With 10 participants, 9 have brown eyes and 1 has blue eyes. So we cannot conclude that there are only 2 eye colors and 90% of the population have brown eyes. But when we get into a little bit of a larger number, so now if we go to 100 participants, if 80 have brown or black eyes, 10 have blue eyes, 5 have hazel eyes, 3 have gray eyes, and 2 have green eyes, this might be more representative of the population, but it also depends on where your population is. So this would be more reflective on the population of Europeans. If we go into East Asia, into China, we're going to see that the portion of the population with brown or black eyes is going to increase, where green, hazel, blue, and gray may decrease. They'll still exist in the population, but the numbers are going to vary. So not only do the number of participants matter, but the location will matter as well. Okay, so then what do we do if we have a small sample size? So this is my flow chart here. For applied linguistics, the general rule is to look at 30 is the magic number. In other disciplines, it would be 50. But for applied linguistics and for your thesis, you're going to look at 30 participants per group. If you have 30 or more, then you can just go right to a parametric test. But if you have a small sample size and you have less than 30 participants, then we have to think of, well, do you have more than 10 participants per group? If the answer is no, then you cannot use a parametric test, or you cannot use a parametric test. You must use a non-parametric test or descriptive statistics. If you have more than 10 participants per group, but less than 30, then you're going to use the Shapiro-Wilk test. And with the Shapiro-Wilk test, if your sample is distributed normally, you've got a normal distribution, so that's that bell curve, then you can use a parametric test. But if the sample is not normally distributed, so it could be skewed, either left skewed or right skewed, then you're going to use a non-parametric test. So again, for the Shapiro-Wilk, you're going to code all the data in Excel and save it to a CSV file. Open JASP. You're going to click on descriptives, select your variables of interest, click on statistics, and click on Shapiro-Wilk test. Okay, let's see what that will look like. So these are the steps. So once you've got your data in Excel, it's saved to a CSV file. We go to the main menu, we open the file, and then we go to descriptives. Up here, we're going to click on this, and then we're going to drag over whatever variables we're interested in. So we're looking at the group and motivation in this case here. And then we're going to go down into statistics, click on the Shapiro-Wilk test, which is under distribution. And then we're going to see the Shapiro-Wilk and the p-value in the descriptive statistics. Here you can see it is less than 0.001. So if the p-value is significant, you do not have normally distributed data and you have to use a non-parametric test, such as a chi-square. But if the p-value is not significant, so it's greater than 0.05, you have normally distributed data and you can use a parametric test, so a t-test or an ANOVA. So that is the rule here. So if we go back to this one here, this is significant. So in this case here, I would not be able to use a t-test or an ANOVA. I would have to use a chi-square. Okay. So again, parametric tests, this is where we've got our t-tests and ANOVAs down in the parametric. The non-parametrics test, the one that's most commonly used is going to be the chi-square. So let's see how this will work. I'm going to stop sharing here. We're going to go live into JASP. Just one moment, and I'm going to share JASP here. I'm going to pull up a different data set. So I'm going to go to my computer and to my research methods example data, and I'm going to use this repeated measures example file here, which is the CSV file, and we're going to open that. Okay, so as you can see, this data is all scale data. We've got an experimental group with a pre-test, experimental group with the post-test, control group with the pre-test, and control group with the post-test. What we're interested in is looking to see if the data is normally distributed, and this would be on the pre-test only. You don't need to look at the post-test. Depending on the type of study, if it's collaborative learning, you should find that the majority of the students are hopefully at the end of the study performing similarly. But at the beginning of the study, you should find a normal distribution in a class. So let's look at the descriptives. And here our variables of interest are going to be the experimental group pretest and the control group pretest. These two groups here, we notice in the experimental group, we've got 29 students. Control group, we've got 31 students. This one's on the cusp as to whether or not you would need the Shapiro-Wilk, but we'll look at the Shapiro-Wilk for this one here because we do have one group with less than 30. We're going to come down to the Shapiro-Wilk test here. And for the Shapiro-Wilk test for the experimental group, I can see that the p-value here is not significant. And because the p-value is not significant, I can go ahead and use a repeated measures ANOVA here. For the control group, we've got 31 participants. It's not normally distributed, but it is over the rule of 30. So I would say go ahead with this particular group. You can go ahead and use a repeated measures ANOVA, but this one is sort of on the cusp. So again, this is where you find the Shapiro-Wilk. It's under descriptives in JASP. So thank you so much for watching this video today, and I look forward to seeing you in the next video.